Hi and welcome back to my channel, or welcome to my channel if this is the first time you are watching one of my videos. This problem that I'm going to go through today is to find the exact area of this square. Can you do it? Can you find the exact area? If you can, let me know what you think that would be down in the comments below, and to help you, I've labelled the vertices here just for clarity and consistency. But it's key to find the exact area of the square. It is easier to find the rounded or the decimal area of the square, but can you find the exact area of the square involving surds? Okay, if you want to solve this problem, pause the video now. Otherwise, I'm going to show you my solution in 3, 2, 1. Okay, so first thing that I wanted to do is to label this angle. Obviously, we know in a square we've got right angles in each corner, so 90 take 15 leaves me 75 degrees. And then I wanted to introduce this line here, okay, going from that point E, horizontal, not horizontal, horizontal, parallel is the word I was looking for, parallel to the base of that square, and the key part there is that it makes those right angles, okay? Then we've got right angle triangles. Now from there, what I can do is I can work out the length from D to F, okay, using cos, or basically trigonometry, but cos theta in this case is the adjacent divided by the hypotenuse. So replacing those with the things we know, cos 75 is equal to df divided by 3. So that length d to f is 3 cos 75. Let's put that on the diagram. Now all we need to work out now is a to f, add the two together and then square it. So it seems pretty easy, right? It should be. Now, to work out a to f, we need to work out one of the other sides, so probably e to f first, and then we can either use trigonometry or Pythagoras. So working out e to f, I'm using the triangle ED or DEF. Sine theta, I'm going to use this time, is equal to the opposite divided by the hypotenuse. And again, replacing those with the things we know. Sine 75 is equal to EF divided by 3. So EF is equal to 3 sine 75. Again, let's put that on the diagram. From there, I'm going to use Pythagoras to work out the length of a to f. Okay, so that's going to be 5 squared, the hypotenuse, subtracted by, or subtract from that 3 sine 75 squared, and then square root it. Now, 3 sine 75 is actually 3 root 6 plus 3 root 2 over 4, the exact value. So I'm going to put that into my equation here. Now, I then have to square that. So that gives me this, 54 plus 18 root 12 plus 18 over 16, which simplifies to 72 plus 36 root 3 over 16, which again simplifies to 18 plus 9 root 3 over 4. Now obviously we need to square the 5, we still haven't done that. That gives me 25, and 25 is actually 100 over 4, and then I can combine those two. That gives me 82 minus 9 root 3 over 4. So okay, again, pretty straightforward. And I've factorised, or not factorised out, I've square rooted the quarter there into a half and put that outside the square root. Okay, so put that on my diagram. I've got a to f, I've got f to d, just add them together and square them. Pretty simple. But, and here's cos 75, written 3 cos 75, written as an exact value. It's not as easy because we're looking for the exact value. Now, like I said there, we've got to add those two lengths together to get the length of A to D, and then we're squaring it because we're working out the area of the square. Okay, this is where it starts getting a little bit more complicated, let's say. What I'm going to do is I'm going to split apart that 3 root 6 minus 3 root 2 over 4 into individual terms. So, okay, 3 quarters of root 6 minus 3 quarters of root 2. Okay, now I need to square this, and I've got 3 terms here. So what I'm going to do, and I wouldn't normally do this when I'm squaring something, but I'm doing it in this case because I've got more than 2 terms, and one of them is quite complicated, that square root at the front. So I am going to use a grid, a multiplication grid. And I've got all 3 terms in there. I've written them in a slightly different order, just because I've put the simplest ones at the start, basically, and the more complicated one at the end. But it doesn't really matter, well, it doesn't matter at all which order you do those in. Okay, so we're going to need more space for this. We're going to need probably the whole screen. So let's multiply these things together. 3 quarters root 6 times 3 quarters root 6 is 27 over 8. And then 3 quarters root 6 times minus 3 quarters root 2 is minus 9 root 3 over 8. And then 3/4 root 6 times this a half root 82 minus 9 root 3 gives us 3/8 root 492 minus 54 root 3. Okay, it seems like we're making this more complicated, but actually this will be a lot nicer at the end. It's going to take a little bit of work though. Next, minus 3/4 root 2 times by 3/4 root 6 is again minus 9 root 3 over 8. And then minus 3/4 root 2 squared is 9 over 8. And minus 3/4 root 2 times by this pretty awful surd is minus 3 over 8 root 164 minus 18 root 3. And then we've got this horrible surd times everything again, and we've already seen two of these, so I'll just put those back up there. We've seen them in the right-hand column. And now the final one, a half root 82 minus 9 root 3 squared is 1/4 82 minus 9 root 3. Okay. From there, we need to collect our like terms and simplify this as much as we can. So we get this 25 minus 9 root 3 over 2 plus 3/4 of square root 492 minus 54 root 3 minus 3/4 of square root 164 minus 18 root 3. Okay. Now, in case I misspoke, it's plus 3/4. I'm not sure whether I said minus, but anyway, you can see it on the screen in case I did misspeak. That's what we've got, and it's quite messy at the moment. We've got two surds, and I'd much prefer to make them into one surd, so we're going to see if we can do that. Right, the square in the bottom corner, so you don't forget what the problem is when we start, or continue rather, going through all of this kind of surd manipulation. Quite complicated stuff. At least I think it could be. To some people, most people maybe. Probably most people would be. Now, I've got 3/4 in front of both of these awful looking surds. I'm going to factorise that out to the front and get this. Right, now from there, I notice that what I need to do really, or what would be better to do, is to make everything of a denominator of 2. So I can do that by timesing the 3/4 by 2. That'll make it 3 over 2. But if I do that, I've got to times the things in the brackets by a half to keep things consistent. So if I do that, I get this. Now from there, I need to spot something else. And really what I need to spot is that the inside that bracket, at least, the 492 minus 54 root 3, that is 3 times 164 minus 18 root 3, that right-hand surd. Okay, now, so what I'm going to do is I'm going to factorise that 3 out of the 492 minus 54 root 3. And that is actually root 3 in there because it's still inside of my square root. I'm going to bring that outside, so I get root 3 over 2 lots of square roots. 164 minus 18 root 3. Okay, now what I'm then going to do, I can factorise the 164 minus 18 root 3, or the square root of that, I should say. And that gives me this. Root 3 over 2 minus a half times by root 164 minus 18 root 3, which simplifies to root 3 minus 1 over 2 times that square root again, 164 minus 18 root 3. From there, I want to put that back inside the square root. So in order to do that, I've got to square it. So I square root 3 minus 1 over 2, and I've got to times it, once I've squared it, by that 164 minus 18 root 3 that I keep repeating. Now, squaring that isn't that bad. It's not too bad. You get 4 minus 2 root 3 over 4. And that will give you 1 minus a half root 3, which is going to be easier to multiply across. That will then give us 164 minus 18 root 3. That's everything times 1. And then everything times by minus a half root 3 is minus 82 root 3 plus 27. And we're going to simplify all of that to give us root 191 minus 100 root 3. And at this point, we're basically there. The only thing we need to change is that 25 into 50 over 2, and that gives us that the exact area of square ABCD is 50 minus 9 root 3 plus 3 root 191 minus 100 root 3 over 2, which is a mouthful, but yeah, that's what it is. And as a decimal, that's about 23.5. So yeah, if you did it as a decimal answer, 23.5 approximately, or rounded, but that is the exact area there. Let me know down in the comments below if you were able to do that yourself, and if you had a quicker way of doing it than how I did it, because I feel at least like my way was quite strung out, but maybe it is the quickest. Let me know down in the comments below. Thank you for watching. If you enjoyed this video, please drop a like on the video, and if you're not already, please do consider subscribing to the channel, because I release a new problem solving video every Monday at 5 PM. As I say, thank you for watching, have a great week everybody, and I'll see you next week for another video. Till then, bye bye. Bye bye. That hand. See ya.